All right, everybody, we're going to cover sections 2A and 2B now from the summer review packet. Now, again, just a reminder, this entire course does revolve around this CED, this course and exam description guide. All the topics that we're going to go through this entire summer review are going to be used throughout each of these 3 units, and you're going to be expected to be familiar or understand where the math is coming from. Here and there, we'll work problems out just to fine-tune a couple of the other skills, but you'll see there's a lot of material to cover here, and that's why the summer setup is done the way it is. All right, let's get started. I do have some bad news before we get started here. There's not going to be any Desmos in this unit. There's no problem, and I tried my best to find a way to get Desmos to be used in this second video. Unfortunately, it's only distributive property, which we see here, and, well, I'll talk about the other part in a second. Anyway, I'm not a fan of calling anything foiling, ever, because it's always just distributive property. Anytime you FOIL something, it's a binomial times another binomial, and it's a very unique case. I will always do my best to refer to this type of math as just distributive property. You multiply the first term by every other term that you see in the second set of parentheses, and you multiply the second term by every other term you see in the second set of parentheses. I'm also old school, where I like to put the term that has the fewer amount of monomials. Right here, you'll see 2x minus 5 versus all of this we have out here. I like to put the terms or the set of parentheses that has the fewer amount of values first, because to me it just makes sense as opposed to seeing something like this, where the 4 terms are first and the 2 are second. It doesn't matter, and it won't matter in the end as long as everything's done correctly, which order you put them in, but I always do my best to put the fewer terms first and the more terms second. All right, let's expand this thing. All right, so we get a final answer here of 8x to the 4th minus 30x to the 3rd plus 19x squared plus 29x minus 35. After distributing, I just combine like terms. One part of these directions say to write the polynomial in standard form. Standard form is understood to be the largest degree value first, all the way down to the smallest degree value in the end. Usually, it's in reference to the variable x. So here we have a degree value of x to the 4th, then to the 3rd, to the 2nd, to the 1st, and now there is no x there. That is technically x to the 0. And if you remember, x to the 0 is just equal to 1. Why is that? Well, if you have x to the 4th over x to the 4th, anytime you had a variable divided by another variable, you subtract the exponents. So x to the 4th over x to the 4th gives you x to the 0. And also, anything divided by itself gets you 1. So x to the 0, meaning anything in 0 or raised to the 0 power, equals 1. So this is in descending order, also called standard form. Let's see what the next problem has. All right, so here we have a distributive property now with 3 terms. Because there's 2 terms here and 1 term here, my first thought is to distribute this 3 to this 2 and this 5, and then take whatever binomial that is and multiply it to this trinomial. You cannot take this 3 times the 2 and the negative 5 and then continue into the next set of parentheses to take that 3 times the x squared times negative 4 and the 2. The reason being goes back to old school multiplication. If you had 3 times 4 times 5, most people would take 3 times 4 and get 12, and then 12 times 5 and get 60. Or take 4 times 5 and get 20 times 3 and still get 60. Nobody ever says 3 times 4 is 12, 3 times 5 is 15, and 12 times 15 is, Alexa, what's 12 times 15?
12 times 15 is 180.
Thank you, Alexa. Don't judge. Anyway, to get an answer here of 180, 3 times 4 times 5 is definitely not that. So for the same logic as not being able to multiply like this, you're not able to multiply this 3 times everything else. All right, let's see if I can solve this thing without Alexa. Our final answer here, 6x to the 3rd minus 39x squared plus 72x minus 30. Not too shabby, even with Alexa's help, I guess. Next up, we have just a simple binomial times a trinomial. What makes this one different? There's a negative lead coefficient here. For the same reasons, I leave my term with 2 first, and anything else second. Our final answer here, negative 6x to the third plus 14x squared minus 25x plus 7. Again, not too bad. How much worse can it get? Oh, that much worse. Anyway, there's a quantity being raised to the second power here, and one of the biggest misconceptions and mistakes that are made in math is that all too often this squared gets attached to this x, and this squared gets attached to this 3. Whether it's positive 3 or negative 3, it doesn't make a difference. Unfortunately, x minus 3, the whole thing squared, does not equal x squared minus 9, or does not equal x squared plus 9 if you treated this squaring in negative times a negative. What this actually equals is a quantity times itself as many times as that exponent states. So if this were raised to the second power, it's going to be whatever's inside these parentheses multiplied by each other this many times. So this ends up being x minus 3 times x minus 3. Now, all of a sudden, I have a binomial times a binomial times a binomial. Because of how I feel comfortable doing math, I always group the second two terms together. Why? It'll keep the smaller amount of terms or the fewer amount of terms first in this x minus 3, and then I'm still able to multiply this x minus 3 times whatever this thing expands to here, giving me more than 2 overall terms. Our final answer here, again, after distributing this x minus 3 times x plus 1, notice I didn't say a FOIL, and then distributing this x minus 3 times this whole quantity here gets me x to the third minus 5x squared plus 3x plus 9. That has to be the most challenging problem we have. Next up, we have a whole bunch going on. I guess I really shouldn't have said anything before. Anyway, I have a binomial being raised to a second power. I have only a few numbers and a bunch of variables, x and h. I would be more concerned about this problem if the directions were to solve for x with having two variables there. Because it just says simplify and to write in standard form, I'm going to perform all the same steps of algebra that I've been doing in the previous few problems. Even though there's variables, more of them in the mix, numbers change, math doesn't. So when it's all said and done, I multiply this binomial times a binomial, do all of my distribution. This is an H here, not a B. I didn't feel like going to correct it, but my handwriting's not the best, let's just say. To get a final answer of x squared plus 2xh minus 6x plus h squared plus 11h minus 9. If you take a look at all the steps that I did up here, none of them were different than the previous slides. Now, when it comes to standard form or decreasing degree values, it's understood that there's a single x here and a single x here. But because the overall degree of this term is 2, because this x has a an exponent of 1, and this h has an exponent of 1, this has an overall degree of 2, therefore it's listed first before this overall degree of just 1 here for the x. Now, usually what happens after distributive property, everybody's very happy and feels content that they've conquered the world of mathematics. Until 2b happens. All of a sudden here now, we already have a problem in standard or descending degree notation. So what could possibly be asked of us here? To factor each polynomial completely. Factoring is one of those topics in math where most students and people don't want to do that. I understand. Unfortunately, it is a huge part of this class where I'm going to factor during the course of a class, and it's going to be expected that you understand how I went from one step to particularly the next. This is a trinomial. I'll briefly review how to factor. The very first thing you do is make sure your values are listed in descending order, biggest degree to smallest degree. This is done. Usually that's the case. Next, you see if there's any greatest common factors, meaning are there any terms in each and every monomial, each individual term, that overlap or they have in common. There's an x here and here, but not here, so there is no x in common. Then it comes down to standard rules of factoring. There's difference of two squares, There's trinomial factoring, which this happens to be a trinomial because there's 3 terms. And then there's something called factoring by grouping. Factoring by grouping is something that occurred on the previous video for section 1B, number 5. In one of the examples we're going to see here, I'll show you what factoring by grouping looks like and how that math was performed, and also how to recognize it. This is a trinomial, so I'm, again, very old school. I always put 2 blank sets of parentheses and hope for the best. The only terms you need to concern yourself with are this first term and the last term. The first term breaks down x squared as multiplication, so it's x times x. The last term still has to be broken down by multiplication. In this case, it's 3 times 3, or it's 9 times 1. You have to pick either a 3 and a 3 to go here and here, or a 9 and a 1. The 1 can go here, the 9 can go here, or flip them, to get some sort of combination to get to this middle term. You have to multiply by the end terms to combine to get the middle. Now, when I say combine, that usually means add or subtract. Now, if you take a look here, do 3 and 3 combine to that 10? No. Do 9 and 1? Yes. So I know this is going to be a 9 and this is going to be a 1. There's a very good chance I might be wrong in where these numbers go, but again, how I feel comfortable solving factoring problems is I don't care where the numbers go, I care where the signs go. Since this 9 and this 1 have to multiply in the end to a positive 9, it has to be either a positive 9 times a positive 1 or a negative 9 times a negative 1. If I combine a positive 9 times a positive 1, or with a positive 1 for those x's, I get that middle term that I need. So it's a plus and a plus. When I say combine, what I technically mean is multiplying the 2 inside terms here and the 2 outside terms here. Yes, they are part of that FOIL setup, but it's a lot cleaner, I think, here to refer to it. So 9x gives you these 2 terms when you multiply them. 1x, they combine to 10. So your factored form completely is x plus 9 times x plus 1. Let's see what the next problem looks like. All of a sudden here we have a trinomial. So I'm going to check to see if I have any common terms. 3 and 5 don't have any common terms, so I'm good there, and there's not an x in all 3. What makes this different is that this lead coefficient, and it's going to be referred to down the road as a, because you have ax squared plus bx plus c as a standard form polynomial for a quadratic, where a, b, and c are your coefficients for a and b, and your c is your constant. So numbers change, math doesn't. I'm going to put 2 blank sets of parentheses. This x breaks down as to x times x, but notice I'm leaving a little bit of room here and here. Just like I break down this 12 into 12 times 1, 4 times 3, and 6 times 2. Again, I'm going to use a combination of 12 and 1, 4 and 3, 6 and 2. But now I have to use it in conjunction with some other value of 3 that'll sit out here now as 3 times 1. I'm going to put a 3 here and a 1 here, only because I know I have an option of a 3 and a 1 or a 1 and a 3, so it's not all that bad. Picking 6 and 2, just because, I'm going to put a 6 here and a 2 here. Since I need a negative 12, I know one of these has to be positive and one of these has to be negative. I'll make this a negative and make this a positive. There is another shortcut out there that says whatever sign you need here in the middle term goes with your bigger number. So let me do that. And if I did my check here, I'd get a 2x for my inside terms and a negative 18x for my outside terms, leaving me with a negative 16x. That is nowhere near the middle term that I need. So I have to go back, I have to try my best to erase all the math that I just did and try again. For me, again, the nicest or cleanest way to do these problems is to just guess and check. My final answer here gets me 3x plus 4 times 1x minus 3. The middle terms give me a 4x. The outside terms get me a negative 9, which does combine to that negative 5. These problems are going to be seen this year. They are a little bit trickier because you have the first lead coefficient of a being greater than 1, but in the end, they are the same exact math with the same slow and steady process to get to the final answer. Now all of a sudden we get to a problem that has only 2 terms. This is a giveaway for one of 2 things: a greatest common factor, which this problem doesn't have, or a difference of 2 squares. The rules of a difference of 2 squares setup are the fact that there's 2 terms, every exponent for a variable is even, and every number visible is a perfect square number. Sometimes you can factor out a greatest common factor number or variable to get those other rules to kind of kick in. Since that step doesn't happen here, I know that this problem can still be broken down into 2 separate sets of parentheses, where I have the y squared break down into y times y. I have the z the z squared breaking down to z times z, and 64 breaks down into 8 times 8. That's why it has to be a perfect square number. When you're multiplying this parenthesis value times this parenthesis value, you need to get a negative 64. In this case here, that makes this one positive value of 8z and one negative value of 8z. It doesn't matter where you put them here because both will technically be correct. These problems don't occur as often as trinomials, but in the end, they are still something you will most certainly see throughout this year. Now all of a sudden we have a chance for a difference of 2 squares again. Unfortunately, this 32 is the only piece of the puzzle that doesn't make that work. But I do have a greatest common factor here of 4. So my first step would be to factor out this 4 here. Now, what's left over doesn't necessarily give me the nicest difference of 2 squares, but it still has the potential to have or leave us with a difference of 2 squares. I have 2 terms, a subtraction sign, and an even exponent, but this 8 is not a perfect 8 number. Some places might say that is a final factored or completely factored form. Others might say this. It's not the most common to see, but if you did multiply this t times this t, you'd get t squared. And if you multiplied this square root of 8 times the square root of 8, you would just get an 8. I don't know how often this might occur in this class or in subsequent courses you take, but this is a true factored form of t squared minus 8. Notice again, the 4 just went along for the ride. The last problem here shows us an example of what factoring by grouping looks like. Notice I have an x plus 3 and an x plus 3 that's common. If you treat this first set and this second set as separate terms, it's no different than saying there's a common 3 in this first term and there's a common 3 here in the second term to be removed or factored out to give us 3 times x plus 2. The same exact math can occur here. Since there's 3 times this x and technically 3 times this 2, it's a term times a term plus a term times a term. This is something times something minus, no difference, something times something. If I removed that x plus 3, what would be the only thing that's left in this problem? An x minus 5. So the factored form here of what was given to you originally of x times x plus 3 minus 5 times x plus 3 is x plus 3 times x minus 5. The order here can flip in either direction. Now looking at this original problem, it makes sense to know that this is a greatest common factored problem expanded to be called factoring by grouping. I'm going to distribute this entire problem out to show you what it looks like in the previous step, and then show you how to recognize when you might have a factoring by grouping setup. If you treat this problem, when there's 4 terms in descending order, as a first half and as a second half, it makes a lot more sense for what you're about to see. This problem here has an x common in just the first half, meaning just these first 2 terms. So x times x plus 3 is what you'd get if you factored out an x from those 2 terms. And there's also a 5 common between this 5 and this 15. So I'm definitely going to factor out a 5 and be left with an x and a 3. But here's the catch. what would this 5 have to be to distribute back to get this term here? Well, it would have to be a negative. And what would this negative 5 have to multiply by to get to this negative 15 that we had in the previous step? Well, a positive 3. And if you take a look here, it has then, by those reasons, and not the fact you want the first half to match the second half, but by those reasons of doing some backward engineering of the distributive property, gets you to a now common term of x plus 3 to be factored out and be left with x minus 5 in the end. We will see factoring by grouping, and we will practice it often throughout this year. That puts a bow on the second video here. If you take a look at the Google Classroom page, you'll see that there is a DeltaMath assignment ready to go. Remember, when you go to deltamath.com, click Sign In with Google with your Valley West credentials, and then from there, you'll be automatically entered into the AP Precalculus Summer Course, where all the review assignments will be there, the previous ones, and even a few of the next ones as the summer goes on. Thanks, everyone.